Yeah.
Okay.
Start.
Center line, vertical movement. This one I'll revolve. Okay.
Okay.
Again switch on the planes. Fine.
Hmm.
Sketch front plane.
Okay.
Switch off the planes. Either you can use the same center line or draw one more center line.
Okay.
Now okay, this is line.
Hmm.
This one revolve. Yes. Thin feature. Now I want this one not 360 degree, maybe 10 degree.
10 degrees to use it.
10 degree line or profile. Thickness is not there.
For revolve, it should be close, right?
Yeah, not only, but thickness you can give.
Okay.
I'm sorry, this has come. That is the problem. This line is. Revolve. Yes. Thin feature. Thickness it is not taking. Section. Maybe this one for this. Why this line is closing? For this we have surface. Okay, I'll show you. We are not in that part, but in surface we can do.
Okay, okay. Here we can put the angle.
Plane.
Okay, okay. Do we can give thickness also, right?
Yeah,
Thickness to it,
we-
thickness and
we give thickness also here.
Okay. It's 10 mm, so we
No.
can make it. Okay, okay.
Unable to thicken feature. Outside thickness.
Hmm.
This one thicken. Thickening is not going much result. Okay,
Yeah,
and
got it.
surface we have not seen, but surface feature. That's why. What is surface is? Last class I was teaching in CAT also surface. Surface. I'm filling up with clay. What is it? Inverting it. thumping it, I'll get the shape of it.
Shape of
This inner surface. Surface design is theoretically 0 mm thickness.
yes.
Practically, it does not exist.
Okay.
Okay. Now I made a 0 mm surface. To that I given thickness.
Okay.
While designing, I use the theory approach where it is a boundary. Okay.
Okay.
A boundary surface, don't confuse. That I will tell. Certain shapes we can't do it. For example, organic shapes. This mouse. No extrude, no revolve. These organic shapes. What is organic is, as per geometry, line, arc, circle. These throughout geometries. But here, nothing is there. Similarly, it is amorphous.
Yeah.
That is why it's called as organic surface.
Okay.
This is organic, where it has got only curvature. For curvature, now I made one curvature only. There is no dimensions for it.
Yeah.
Okay. How we form it? Two things. One is functionality. Second thing is aesthetics in surface. Functionality is it has to cap,
Okay.
lock it.
It has some function.
It has function.
Yeah.
From surface, we have to develop it. Okay. You understood this?
Understand.
Still, surface design what means in industries. Last class I will show you. Car and motorcycle. First, they'll do clay design. What is clay design is?
This one.
You have seen this clay design.
Yeah.
This is a polymer clay where it will not set. It is always moist. Okay, it is like wax.
Okay.
With this clay, they will design the car. This is like artisan scraping it. Okay. It's fully a craftsman work. This craftsman work, after doing it, they will scan it. Where they scan it. Next one. After doing this model, they will scan it. Car clay model is scanning. 3D scan. They will scan it like this.
Okay.
Because like these shapes and all, we will not get it. Geometry is not there. Therefore, they will scan this one and they will make a geometry like this. 3D scan for clay from clay model. This will not have any volumes.
Okay.
It will have only surface area and boundaries. Therefore, surface is a boundary with 0 mm thickness. Practically it does not exist, but theoretically it do exist. How it is made practically possible is by adding thickness or volume to it. You understood?
Yeah.
Yes, sir.
Okay. Example is Italy plate is there. Italy plate means you are applying oil, the thin film. That is a boundary.
Yeah.
Later, a film of oil is there. Above it, we are pouring the batter. We are getting the shape like molding. Similarly, how the shape Italy has to be like this. Okay. Because initially, they with the sheet they made it and they poured it. But when it comes to like this car design and all, it will be made with this clay, and this clay design will be scanned. It will be in either 1:1. It will be there here. It will be in 1:1 or scaled model. Scale means 100 feet means it will be made to 5 feet.
5 feet.
To
Yeah.
1:50 scale, 1:20 scale like that. Then only we will get like this kind of organic surfaces. Can you see these are organic?
Yeah.
There is no line, no arc, no circle.
Yeah.
Above it, they will also see this one. Above it, they will also add up wrappings. They will make like
Okay.
this. In certain places, clay modeling they will do with car clay model with mirror. One half they will do it, and another half it will be mirror. Center they will be having a mirror.
This.
For this separate institute is there. one half here.
Okay, okay.
Other side is there, right? Only one half is there.
yeah.
Other side mirror will be there.
Okay.
This is the full. Okay. This is one technique. With this only aesthetic parts. These things and all we can make it in solid itself. For example, some aesthetic parts. What are the aesthetic parts? Organic parts and all made like this. Okay. Half will be done here. Motorcycle, everything will be done using this one. Therefore, for surface design, it is like mathematics. You have studied 4 papers in mathematics. Why you are differentiating cos x minus sin x purpose? No applied, because there is no applied mathematics.
Yeah.
Okay, what application is there? Why we are integrating? Why we are differentiating? Similar to that, you have to study this.
Okay.
When industries, depending upon industries, you will know how the surface is there. Okay. What I acquired my experiences, certain things I can transfer, certain things only in industry is there, where you will see the practical application of it. Here I can't show practical application. One is this one.
Okay.
Scan motorcycle, organic surfaces. See this one. These and all they would have been done using clay,
Okay.
and they'll check the ergonomics and they'll do it. Understood?
Yeah.
This one. Bike and car and all mostly design like this. Even aircrafts, they do like this only. This you never heard of it? This clay?
No. I just thought that these people do this design, just have some concept and
Many
some,
things are there.
some software.
Software
Design the
they
part.
this is an ocean.
Yeah.
It will vary from different methods.
Please
Okay.
do this.
I do know certain places in this. I'm swimming there and I'm teaching you also to swim. This is vast. Okay. We did get one project from industry, and this one system is overloading. Like this, I have to chain link. This is this got movement, but it is overloaded.
Okay.
They want chain to be entire project. The system got overloaded and crashed. This will be rotating. Only thing I am able to further add up a link, closing link to it.
Okay.
It is. It's moving. Now you seen it move. Push and it is totally tracking. We want this project to chain up everywhere from here fully sprockets everywhere chain has to go.
Okay.
System is not supporting. We stopped it. Some chemical treatment plant, they want it. Everywhere they want sprocket chain and it has to rotate. They said, let me try, I said. Okay, today we go to class. You have doubt in extrude what? Up to vertex, up to vertex. This is the vertex. Okay, not 2-point connecting. Here, what all the vertexes? 1, 2, 3, 4, 5, 6, 7. These are all the vertex. Even this 2 end also vertex only. Okay. This why I am using pocket is because pocket only we can see up to vertex. Extrude material we can't see. Extrude cut up to vertex. This is my vertex. You see? To this vertex it will stop. Section it. Understood? The vertex is. Now up to here we'll give the same thing. Vertex, right click. Clear selection. This is my vertex. Okay.
Okay.
Now fully it will be there. Even this is also vertex only. Definition, clear selection up to this vertex. Okay. All up to vertex. Done. Today classics, we saw yesterday classics. Sweep and sweep cut, loft and loft cut, boundary. Here we'll sweep. Sweep is my cross section to a path. One cross section toward the path. This, for example, sweep. I'll show you. Now I don't have any part samples. Maybe this one will take. Okay. Section, front line, and grading front line, 3-point arc, taking center line, vertical, this point and this point with respect to center point. Symmetric. Select outer and center. Symmetric. Evenly distributed. Similarly, this point with respect to center. Symmetric. Now you see. Can you see symmetric? Now let this be tangent. Okay. Now this is my path. I want like this section rectangular. For this, switch on the datum plane. Okay. Or to this here, I want to create my own datum plane. Switch off datum plane. Create. This is reference geometry. Plane. Select the point and the line. Point and line control.
Okay.
Normal. One path is there.
Normal to the line.
Normal to this. Now select this. Go to sketch. Here center rectangle. Point. Okay. Now features. Sweep. Sketch profile. This is my sketch. This is my path. Understood?
Okay.
This I could have done in extrude itself.
Okay.
Correct. Extrude itself I could have done it. But I want to show you how the path is. Okay. Spring and all done using this one only. Spring. Sweep command. I'll show you later on. Now spring means you will go to curves. Here helix will come. Now this one you understand. Maybe another example will go. I'm taking SP line. SP. This is a curve. Here I want to create a datum plane here. Features, plane, select the point, control and normal to it.
Okay.
Here again sketch, done. Sweep, sketch default selected, path is my path. Understood?
Okay.
Now again path, right click, show. Sweep cut. Here circular path. Can you see here? Sketch no, circular path. Diameter 10. What is my profile? Center of the profile, a circular path. Can you see? 8. Circle is defined. Why to draw it? That's why it is predefined. Sweep and sweep cut. Understood?
Yes.
This where it can be used is here to this uniform I'm going to give a thickness. The command name is shell. Later also we'll see this surface uniform wall thickness 10 mm. You see here shell. Now we'll give 3 mm. Okay. Now switch on the plane. Sketch right plane, front plane I'm selecting. Now this is my boundary. Select this. Now convert entities. Can you see? This edge is converted. To this edge, select this, make construction. This is construction now. There is edge, can you see here? Space bar, normal view. Here I am clicking on handle. Understood? How sweep is coming. Okay. Now for this sweep, select circular profile path. Understood?
Yeah.
In this options, merge tangent faces. It has to take inside, somewhat inside. Then we have to cut it. Okay. Understood with this?
Yeah.
It's taking processing. I'll show you what it is. My path should have been a little more. Now this end is not matching, right?
Yes.
This end matching only, it is here. Align with end faces. Can you see?
Okay.
Understood?
Yes.
Sweep. Next one is loft. How the loft will work is two different cross sections. Okay. Now switch on the datum plane. Sketch. One. And again create a new datum plane. From right plane, what distance I want? Say 150. Okay. Here, one more cross section. Space bar. Circle. Here, loft. Profile 1. Profile 2.
One second.
Two cross sections. Two cross sections are there. How we are creating is one cross section from default plane. After that, I am creating offset plane. How we are creating offset plane? Plane. Select the plane. Distance. It can be anything. Okay.
Okay.
Now this has got four sides. Now I'll go for triangle sketch. Or a standard shape hexagon. In between these two, loft. Already first sketch is this one, second sketch. Here, click this. Okay.
Okay.
And you see the twist will be there. You go. Okay.
Yeah.
Understood?
Yeah.
Because it has got 6 sides and 4 sides.
Yeah.
4 and 6 is matching like this. Understood?
Yes.
Similarly to this is loft cut. Okay. Here one section. Sketch here. Loft cut 1, 2. Okay.
Okay.
Now with this loft, what is boundary? Again, there is boundary cut and boundary is there. From here again I am taking plane, flip offset, say 150. Here I have got one extrude. Mid plane. Earlier sketch was there. Now this boundary and this one boundary. Boundary base. First boundary. Second boundary. Can you see? Understood?
Okay. Meanwhile, we have two different parts.
Yes.
We can connect them through this boundary
Yes.
by matching the two surface, right?
With 2 boundaries.
Oh,
Understood?
understood.
This no need boundary. This can be between these two things also we connect.
Okay.
Now first loft also introduce. But switch on the data. Show. Right click. Show. Because earlier the twist was there. Now without twist you can do is boundary 1,
2.
done.
Yeah.
Similarly boundary cut. Here boundary cut. Here if you go full it will go cut. Boundary cut means first this boundary and this boundary it will go full we don't want. For that what we can do is create one small extrude cut, say on 10 mm. We have one boundary, right?
Yes.
Sketch. Okay, 2 boundaries. Boundary cut 1, 2. Okay.
Okay.
Understood.
Yes.
Loft, we want section. Boundary, solid itself, we can select the boundaries.
Okay.
Today,
You just extruded some 10 mm part right on both sides.
yes.
So why wait? If you don't do that, what will happen?
Oh, don't do that means there is no boundary. Full will go.
Everything will go.
Yes, because there is no boundary,
Okay.
right? See this boundary,
No, but
this
we,
boundary.
Okay, we just okay. We
See, this boundary and this
create
boundary.
the surface first, boundary first.
See, the whole thing is there.
Okay.
Boundary cut, what will go? Full
Okay,
it will go.
okay.
Correct. It will not have a proper shape. Understood?
The shape it will not have. Okay.
Yeah,
So it
that's
will cut
why-
this square part.
Yes,
Like,
that's why I have mentioned this.
okay, created some two boundaries and then we did boundary cut.
Okay? Understood?
Understood.
Okay?
Yeah.
So today class we saw sweep, sweep cut, loft, loft cut, boundary, boundary cut.
Okay.
Okay. This practical examples you have to search in your book. Okay?
Yeah,
Okay.
we have a book, so we'll practice.
Here I am teaching only sin x cos x.
Yeah.
Application you have to put your head. Understand?
Yeah.
Application you have to put it. Okay. You should not copy my own application. Mine will be different. Certain things parameter. Okay. You can also find the same thing, different application. Okay.
Okay.
Let's remove. Yes.